All right, looking at chapter 2 here, we're dealing with radical functions and equations. First thing, we're going to identify the properties behind these functions here in 2.1. So if you haven't already done so, we're going to work through our getting started and our constructing understanding. What are the domains and ranges? Got to remember about these things. So, domain, that's your x. So remember, this is my domain. Get off my range. Domain is x, range is the y. So we're looking at all the possible x values that we can have. In the domain here, because this first one is a straight line, we can use any x value and plug them in there. So we've got x as an element of the reals. For the range, if we can use any x values while we plug them in, those ends are going to go on and on forever in each direction. We're also going to be able to pop out any y values. So y is an element of the reals. Let's take it over into now our range, or their second one now. We got a quadratic. If we look at this, our vertex is at 2, 1. And it's opening up. So back looking at what we did with the opening up, down, end behavior, it's a quadratic. So the ends go in the same direction. And it's a positive leading coefficient, so it's ending going up. So in this case, I can use any x values and plug it in there, no problem. But I can't get any y values. If we look at that graph, it starts at 1, and all of the graph is above that 1. So y is greater than or equal to 1. Let's take it to the radical part now. So working it through here, let's create a table of values on x and root x. So y equals x. If x is negative 4, y is negative 4, negative 3, negative 2, negative 1, negative 0.25, 0, 0.25, 1, 2, 3, 4. They're the same all the way through in all those. If we graph that, it would look like this. So there's y equals x. Now what would happen if we take the square root of the x? So when we take the root x, we're taking our x value, square rooting it. So square root of negative 4, can't have that. It's an imaginary number. Square root of negative 3, can't have. Can't have, can't have, can't have. Oh, we can have this one. Square root of 0 is 0. Square root of 0.25 is 0.5. Square root of 1, that's 1. Square root of 2 is approximately 1.4 dot dot dot. Square root of 3 is approximately 1.7 dot dot dot. And then square root of 4 is 2. Okay, so that should be a 2. Make that a 2 better. There, it's better. Okay, so let's graph this one. I should have done them in green because I'm going to graph it in green. I can't, anywhere where the original graph was below the x-axis, we can't have. So it's going to start at 0 and 0. But then notice this. The original was 0.25. If we take the square root of a decimal like that below 1, the number becomes bigger. So it actually goes up to 0.5. And then at 1, it comes back to 1. Those points are the same. It's an invariant point. It does not change. So far we've got the point at 0 and 0. We've got 0.25 and 0.5. We've got 1 and 1. Then we've got 2 and 1.4. A little bit under where it was originally. Then we've got 3 and 1.7 and 4 and 2. The graph is going to be a nice curve that looks like that. So that's y equals root x. Domain on the original one, on the red line. It was a straight line, xer, yer, we just talked about that. But as soon as we do the square root, we now have that your x value, it can't be negative. It has to be greater than, but it can equal 0. Then if we look at our y value, we can't have a negative y value. So if the x value has to be positive there, we can't automatically somehow get a negative y either. So it has to be greater than or equal to 0 as well. So we call a radical function one that has a radical, square root sign in there. The square root of a number is only defined for non-negative numbers. So the domain is a set of the values where the y value is greater than or equal to 0. So the x values that go with that range. So here's the basic graph of y equals x, root x. Like we just said, the domain was greater than 0 or equal to 0, and the range is also greater than or equal to the 0. The graph starts at the origin and goes only in one direction. Now if we do some moving of the original graph, so y equals x plus 4, we slide that to the left 4 units. You can see it in the red there. And then at that point we do the square root of it. We can go into the negative x values because of this. I just can't have x plus 4 being a negative. So that x plus 4, the radicand, has to be greater than or equal to the 0. And then we solve for the x. So isolate your x, so subtract 4 from both sides. That gives us our new domain where x is greater than or equal to negative 4. The range that goes with this, I still can't have anything below the x-axis. So if my range is y is greater than or equal to the 0. And notice that it opens up to the right. Let's look at the next one. We got a question. What is the domain of this function? Y equals root x minus 3. You can go to the bit.ly link here and punch that in for yourself. So pause the video at this point, do your quick vote, and then come back and continue. Looking at this next graph. The graph illustrates characteristics that are common to all graphs. So first thing I talked about was invariant points. The points that stay the same. We've got two places that happens. When x is 0 and when x is 1. Because the square root of 0 is still 0, and the square root of 1 is still 1. The points where those y-coordinates lie on both graphs, we call those invariant points. Where the graph of f of x lies between the graph of y equals 1 and the x-axis, that means, what I said, when the value was less than 1, in our example was 0.25, when you take the square root of that, it actually goes above the graph. Because when you take the square root of a number between 0 and 1, it actually gets larger. So the example we use was the square root of 0.25 is equal to larger than 0.25, which was 0.5. Next characteristic there. Where the graph of f of x lies above y equals 1, when you take the square root of a number larger than 1, it gets smaller. For instance, square root of 4 equals less than 4, which is 2. And where the graph of f of x lies below the x-axis, the graph does not exist. We cannot have any graph below the x-axis. So nothing underneath here. We're not going to have any graph at that point. And finally, these characteristics can be used to sketch our graph as we go through. Let's look at our first example. Sketch the graph of y equals root f of x. So here's our original. Table of values if you need. We're going to look at some of the key points along there. So we know that anything below the x-axis, we're not going to have a graph there. The square root of 0 is 0. So first part is we're going to start at wherever it touches the x-axis, it's going to stay there, invariant, same spot. So we know that point. So we're looking at where we're going from here, start at this point, and then we know that there's also another invariant point, and that's when the y value is 1. So when the y value is 0, that's invariant, stays as 0. When the y value is 1, the square root of 1 is 1. So let's look at where the y value is 1, and that's right here. So I've got to make sure I hit those 2 points right now. Those are our invariant points. Invariant at y equals 0 and y equals 1. Can't have anything below the x-axis. Now let's go to another point that we can see. I've given us this point, the y-axis, when y is equal to 4. So original, when y equals 4, the square root of 4 gives us 2. So now we need to draw this one at 2, directly underneath it. Then we've got way up here at 8. When y equals the 8, that's another point they give us, 2, 8. This one was x equals 0, y equals 4. This one is x equals 2, y equals 8. So the point is going to be 2, square root of 8. Square root of 8 is about 2.8. So 2.8. Got to hit that point as well. And remember that thing. When we are dealing between 0 and 1, we're going to be above the line. When we go past 1, we're going to be below the original line. So from 0 to 1, I need to be above the line, above the original. See how I'm drawing it there, above. And then below, going through those key points. And that's a nice curve that goes through there. Perfect. Let's look at the next one. Oh, sorry. We've got to do domain and range first before I move on. Originally, the domain of the red line was XER. But we can't have anything where the original graph goes into the negatives on the y, below the x-axis. So it starts right there at -2. So our domain is x has to be greater than or equal to that -2. We're looking for where does it touch the x-axis, so the x-intercept, and everything is to the right of that x-intercept. X is greater than or equal to -2. Our range, we can't go into the negatives, so it's y is greater than or equal to the 0. All right, let's look at the second one now. This one's going in the other direction. So again, anything that's below the x-axis can't have a graph there. So we're going to start with it at the x-axis. When the y is 0, So that point is x equals 6. Actually, you know what? I'm going to make a little table of values. X, y equals the f of x, and y equals the square root of f of x. So we've got 6 and 0. Original point was 6 comma 0. It's now going to be 6 comma square root of 0. Same, invariant. At the next point that we've been dealing with is an invariant. When y equals 1. That's 4 comma 1 originally. It's also going to be 4 comma 1 because the square root of 1 is 1. Those are our two invariant points. And we remember that if we're graphing this, if we're between 0 and 1, our new graph is going to lie above the original. So we can draw that part. Now let's go to our next one. They've given us some points that are on there. When they put these dots, this is the dot we're looking at. 2 comma 2. We're going to take the square root of the y value, so square root of 2, which is approximately 1.4. So we're looking at 2 comma 1.4. Then the next one that we have is 0 and 3. So we're taking the square root of the 3, which gives us approximately 1.7. Connect those dots in a nice curve, and we're good. So we can travel into the negatives on the x there, because that keeps going on and on to the left, but we just cannot go below the x-axis on any of these. Let's look at our domain and range. Originally, the domain was XER, but now it starts here at the 6, and it goes to the left. So we've got x is less than or equal to 6. And again, the same thing with the y. The y is above the x-axis, so greater than or equal to 0. So this is what we were just talking about. We're looking at on page 83 there. In that second example, we have, actually, sorry, it's on the page 85. If we look at this, we've got, going to the right, the function y equals f of x and y equals the square root of f of x have different domains because the square root of a negative number is not defined. That's a key there. And if x is less than negative 2, then f of x is negative. And the square root of that is not defined. The ranges are different because we're just dealing with the principal square root. If you think about before when I said if you take the square root of a number, use plus and minus. We don't worry about that here because we're told, we're given the square root already in there. And we're using the principal square root, which doesn't have a plus and minus in front. It's just the positive square root of f of x. Now let's look at what happens if we're doing quadratics. So we did linears. Now we've got to look at what happens with a quadratic. So, if we start with our regular quadratic, looks like that red line right there. A negative 3, we got 10. Negative 2, we got 5. We don't have any values in here that are below the x-axis. They're all positive numbers. So they're all going to be defined when we take the square root. So now we take the square root of the y value of that 10, and it gives us 3.2, 2.2, as you can see. And the graph goes out to the right and the left from the point. Remember, our invariant points are always on 0 on the x-axis and when y is 1. We have an invariant point there when y equals 1, but we don't have an x-intercept. So we're just going up from the vertex point there. The domain of the original was XCR, and the range was y is greater than or equal to 1. When we do the square root, we still have the same. I can still use anything for x because I'm putting in a negative value for x, but if I square it, it's positive. There's no way that I can get a negative number by squaring it and then adding a positive 1 to it. I can't get into the negative values. So it's XCR for a domain. Your range, hey, it's all above the x-axis, so it stays the same from that invariant point and up. And the only invariant point that we have is 0 and 1 because it doesn't cross the x-axis. At this point, before you start getting into your number 2, there is a think further on page 85 and at the top of page 86. Please do those for yourself so you can start explaining what all this means. Bring it, tie it together. And for your viewing pleasure, before we get into our example for number 2, we're going to look at their example so you can see how it works.
Part A. For the graph of this quadratic function, y equals f at x, sketch the graph of y equals root f at x. State the domain and range of y equals root f at x. Since the square root of a negative number is not defined, any part of the graph of y equals f at x that is below the x-axis will not be part of the graph of y equals root f at x. The square root of 0 is 0, so the points on y equals f at x, where y equals 0, will also be points on the graph of y equals root f at x. The square root of 1 is 1, so the points on y equals f at x, where y equals 1, will also be points on the graph of y equals root f at x. So, I'll mark points on the graph where y equals 1. I need another point before I can draw the graph, so I'll look at the vertex. At this point, x equals 1 and y equals 9. The square root of 9 is 3, so the point 1, 3 lies on the graph of y equals root f at x. Now, I can join the points with a smooth curve to draw the graph. The domain of y equals root f at x is any value of x that is greater than or equal to negative 2 and less than or equal to 4. The range is any value of y that is greater than or equal to 0 and less than or equal to 3. Part B. For the graph of this quadratic function, y equals f at x, sketch the graph of y equals root f at x. State the domain and range of y equals root f at x. The graph of y equals f at x lies below the x-axis for values of x that are between negative 4 and 0, so this part of the graph will not be part of the graph of y equals root f at x. Just like in part A, I can mark points on the graph of y equals f at x where y equals 0 and where y equals 1, because these points lie on both the graph of y equals f at x and the graph of y equals root f at x. I need to find a couple more points before I can draw the graph. This point has coordinates x equals negative 6 and y equals 6. The square root of 6 is about 2.4, so the corresponding point on the graph of y equals root f at x will be negative 6, 2.4. This point is 2, 6. The corresponding point on the graph of y equals root f at x will be 2, 2.4. Now I can join the points with two smooth curves to draw the graph. The domain of y equals root f at x is any value of x less than or equal to negative 4 or greater than or equal to 0. The range is any value of y greater than or equal to 0.
Ooh, intriguing as always. Let's get back into ours now. So we're going to sketch these graphs at this point. So remember, first thing, anything below the x-axis, no go. Anything that is an x-intercept, that's invariant. So we start with that. We got invariant there, we got invariant there. Square root of 0 is 0. Then we got another invariant points to look for. That's when y is 1. The square root of 1 is 1, so it's going to stay the same. So any place where it crosses y equals 1. And the x-axis is y equals 0. So those are the two places we're looking for invariant points. We've got those drawn in there. Now we have to remember, if we're between 0 and 1, a fraction, a decimal answer there, we're going to be above. So when I take the square root, it becomes a larger number. So it's a curved line above the original. Then let's pick off some other points. They give us some other ones. They gave us that x of 0, x, f of x, and y equals root f of x. I'll set up my table of values again. We did our first one at 1 and 0. Stayed at 1 and 0. That was this one here. We had a 5 and 0, which stayed at 0. We also have those ones, but I'm not really sure what they are. But I know the invariant point was when it was 1. I can't put those points really down because I don't know them. But I can put these 2 points. When they put a bigger point there, they're saying it's exactly that spot. So we have x of 0 and y of 5. 0, 5, that's this point here. We're taking the square root of 5, which is approximately 2.2. So 2.2, right there. So I've got to get through all of those points. Then we've got the other side. We've got 6, 5. We're again taking the square root of the 5, which also gives us 2.2. And we've got to get through that one as well. So a nice curve that's going to go through all of those. We're graphed. Just got to do the domain and range at this point. Domain. I have everything to the right of the x-axis, or x-intercept, and to the left of the x-intercept. So we have two different parts that we have to look at. The left side is x is less than or equal to that 1. We also have x is greater than or equal to the right of the 5. So our two spots. I'll highlight them for you. And then if we're looking at the range is going, again, same as it's always been. Y is greater than or equal to the 0. All right, let's go with this next one. Starting again. Anything below the x-axis, no go. We're not drawing it. If it's on the x-axis, 0, it's invariant. 0, invariant. Let's draw those ones. So that's at -3. So that's again x, y equals f of x, and y equals root f of x. So we had -3, 0. That's going to stay the same. Invariant. And we had 3 and 0 stays at 0. We also have to draw wherever it was y equals 1, invariant at that point as well. Then they give us 3 other points that we could be working with. We don't have to do all of them, but you can. If you wanted to do them all, I'm just going to do this one that's up at the 9. 0, 9, square root of 9 is 3. We could also do the square root of the 5 here, which we might as well do. -2, 5. So we're doing the square root of 5, which is 2.2. So now we're at -2, 2.2 right there. I could also do the point over here that they've identified, which is 2, 5. Again, square root of 5, which is about 2.2. Right there. Connect our dots. When we're between 0 and 1, we're above the original, Then we go below the original, above the original. It's not that good because I missed a couple spots. It looks like that. Very similar to the one you saw right there at the bottom of page 86 on their solution. Domain and range again. X is between this time the -3 and the +3. And then, same as always been, y is greater than or equal to the 0. Oh, but it's also less than, so I gotta stop here because we do have a stop spot, which is our highest value. So let me redo that, sorry. 0, y is between 0, which is our bottom, and our 3. So there's your domain and your range. All right, let's move it to a cubit. Trying to get tricky here. Doesn't matter. It's still all the same. Anything below the x-axis, we don't draw. If it's on the x-axis, it's invariant. So we've got two invariant points there. And then we've got, when it's 1, we've got to hit through that point as well, when y equals 1. They're giving us two other points to work with. They're giving us this one, which is -0.5, comma 0.125, x, y equals f of x. And we're going to do y equals the square root of f of x. At -0.5, we got 0.125. Taking the square root of 0.125, we know if original was between 0 and 1, it's going to be a number larger, and it is 0.35. So it's larger than what we had. So it's above. So we can go up and back down to 0. Then from there, we're going up, again, above the 0. Or sorry, between 0 and 1, it's above the line. And we've got this other point at 1, comma 2. Square root of 2 is what we're looking at, which is approximately 1.4. 1.4. And there, that blue loopy line, that's our new graph. Domain and range. Domain. X is starting at -1, and then it goes on and on forever to the right. So our x value is greater than or equal to -1. Our y value here, because this right arm keeps going on and it goes up, where y is greater than or equal to 0 again. All right, so using graphing technology to be able to work through this one now here. Two different ways that we can do this. Method number 1, which they don't show in the book there, we could graph the left side as y1. We could graph the right side as y2. And then look for the intersection point of those two graphs. The problem with this one, even though it's a little bit easier to just punch it in left side, right side, and then look for the intersection, the problem is that you don't know how high up and down, or right or left, to find your intersection point. So I'm going to go with the way that they show, and I'm going to use the 0 method. Although this method here would be fine. Root 3x plus 2 equals -6 plus x. We're going to equate it to 0, and we're going to look for the zeros of that graph. So we're going to add 6, subtract x, equals 0. We make it equal to 0, and now we look for the zeros on our graph. So let's plug that in exactly as such. So y equals y1 is the square root of x, 3x plus 2. end that bracket, because we want to end the radical sign, plus 6 minus x. Then we're going to graph that. And we're looking for where it crosses the x-axis. I can see that, oh, it looks like it's going to cross a little bit more to the right of where I am. So I got to go back to my window, and I'm just going to increase my x max. Let's try 15. See if that helps. Let's graph that again. Oh yeah, there is where it crosses the x-axis. So I'm going to look for the 0 at that point. Second trace or second calculate there. I'm looking for the 0. Enter. I need left bound, so I need to go as close to that as I can. And that looks pretty close. Enter. Now I need right bound. Notice that the little arrow says I'm looking to the right. So then I go to the right side of that x-intercept. Good, I'm a bit below it now. Got to look in between those two arrows. Enter. And it tells me that my 0 is at 12.2 and y is 0. But I know the y is 0 because I just said find the y of 0. So we're looking at an x equals approximately 12.2, it said, to the nearest 10. There's your answer. Work through your discuss the ideas then to help you to explain what's going on with all these.